Hi and welcome to Unit 5, People Perception Part 2, Face Recognition of this course of Perception with ROS. So in the previous unit you learned how to detect faces, not recognize them but detect them. In this unit you learn how to recognize faces. So your robot will be able to detect who is who, know who is who. So you're going to work in this simulation with fetch robot here and three very distinct persons: Naoko, Bob, and the standing person. So you learn how to recognize their faces, the different faces, and give them a name. That's what you learn. So let's get started. So there are many packages to do face detection, face recognition, sorry. The one that you're going to learn here is a module in Python named face recognition that you have the link in the description, the link here. And it basically does other stuff, but essentially what you'll do is something like this. So you'll detect the faces of the persons that you detect here and give them a name, and they can be virtual or real. Of course, this is applicable for real persons. Okay, so let's close this. So we are going to comment step by step the Python code that you'll need to create to make this recognition. So the first thing is importing the modules that you need. So you need CV2, so OpenCV. You need CVBridge to retrieve the data from ROS cameras to OpenCV, as you learned in the second unit of following the line. And then sensor messages, image, and ROS package that just to maybe get some paths to your packages. So that's it. Then you'll have to first get the path to the face recognition package, to your face recognition in this case. So you'll create a package called, you guessed it, my face recognizer in this case, where you'll have some images that your software will use to make the detections. So for example, you have the Bob image or Naoko image, and the images are exactly these images like this one, for example. So here you're retrieving the path to your package, in this case face detection recognition package, in your case would be my face recognition package. Then you have to retrieve that file. So you have to put the path where you stated, where you have the image. In this case, this one is the standing person image. Okay. Then what you'll do is load that image into the face recognition modules and create this person image variable. And then what you do is from this image, you'll get some face encodings. So you'll get all the features unique of this person that identify that person. And this is how you'll detect different faces. So one thing is that you can do the detections as far as you want. The only problem is that if you give it images this small, it's very difficult for the software to get any features like you would. If you see a person very far away, it's much more difficult that you know who it is than if you have a person a meter in distance. It's exactly the same thing. So you have to get close to the person to make a good detection. Okay, then you initialize some variables and you resize the image. Why? Well, it's the same thing that we did with the following line, that we cropped the image to go faster. It's the same thing. We resize the image so that we can work with it better. That's why I told you that the image has to be close, so that when you do it smaller, then you get better features that if it's very far away. Okay? But resizing it to the half, so here you're doing it half the size in X and Y. Okay? But you're doing the video capture. You're doing the video capture. So it's not the image that you gave, but the video capture. Yeah? So the video that you're getting from your ROS system. Okay? Understood? Yeah? So once you got the image that you'll use for the encodings, you created the encoding, you got the video capture, and you resized each image that you get from the simulation or the real robot, then you work with it. This is like the core. So here we have this, if process this frame, what we do is process one frame, we process it, the other one we don't. The other one, the next one we do, the next one we don't. This way we do it faster. We don't have to process each frame. The persons won't move so fast that this is critical. This way we go faster. Then what we do is this small frame, which is the video feed, it's not the image, it's the video feed. We now do face encoding, face locations, and small frame. So what we do is here we get the video frame and we get the face locations. So where it's detecting some face. It's doing face detection in this line. In the second line, what it's doing is, okay, in these locations, search for an image, and it extracts the encodings. It's like the fingerprint of faces, if you get that idea. This is the unique representation of the face that it's detecting. So once you have it, you say, okay, I detected these locations, I detected these encodings, because you can detect many faces. So now we go for each face encoding. We now compare this face encoding with this standing person face encoding in this case, which was this encoding. So this fingerprint image representation of this face, the standing person, only that one. And then we do a match. If it matches, then you detected that person. And you say, hey, I detected standing person. And then you append the names. So you face names, append, and the name that you detected. Okay? This is just for detecting one person. Okay? Now, once you have made the detection, we've done all the work, really. Now we have to superimpose on the video feed that red box that we saw with the name. So now we have to get the image. So there we go, the video capture, and we have to multiply it by 2. Why? The top, right, bottom data. Why we have to do this? This is extracted from the face locations. Remember that here, let's see, where did we do that? Yeah, so here the video capture was divided by 2, so half the size. We made all the locations based on that. So the coordinates here, so the face locations, will be based on this image that is half the size. So the location, so top, right, bottom, left, will be divided by 2, the values. So now we have to multiply it by 2. If you divide it by 3, the image that you made the detections, then you would have to resize here again, okay? So bear this in mind. It's a place where you can make mistakes. So once we have it, you see, now we say, okay, we draw a rectangle in this location, we draw a box, and then we put a name. So we put a name here, put the text. You see that we're drawing another rectangle here that we do -35. Well, it's depends on how you want to do the box. You can do it as you wish. You can do also, remember, CV, OpenCV allows you to do circles, allows you to do anything you want. But basically this is to create these tags, okay? And the result should be something like this. So you are detecting faces, because here you are detecting faces, okay? Face locations, and you have them. So you'll draw them. But the name will be unknown, okay? Why? Because the name, when we do this, if we don't detect something, it will be unknown. That's why we put unknown here. But standing person makes the match, so we put the name, standing person. Yeah? And we do this for each face names and for each face locations. We do a zip, and then we match the names to the locations. Understood? Okay, fantastic. So here is the code combined, is all the things that we talked about. So steps, you have to create a package, and then you have to copy the images of the persons if you want them. If you want to generate the images yourself, you're free to do it. You just have to go to the simulation, go here, and then, for example, I want to do Naoko's face. So I'll get Naoko, and I'll just do a print screen. Cut this, and that's it. That's one way. The other way would be do a ROS run RQT, so ROS run RQT image view, yeah. Select an RGB, for example, this one, and then get the robot close enough to make the photograph. This way, you guarantee that the images, the feed of images that you input in your algorithm has the same quality as the photograph that you do. Okay, depends on what you want to do. This one is a bit more complicated because you have to move the robot, but as you wish. And now you have move fetch robot here. You have an example provided by fetch. That's what it does, is move the robot close enough and move the torso up so that you can see the faces of the persons. So we're going to launch that right now. So let's do that. The first thing. Oops, sorry. So we get this. We do this. Okay. Now it's moving. All right. It will move 1 meter. It's exactly the same thing that you did for the object recognition. You remember when you had to get close to the table, and when it gets close enough, it moves around 1 meter. You see the countdown here? So 1 meter reaches the position, and then it starts rising. You see, rising the torso. Okay. So we'll wait for that. Okay, done. So let's have a look. if more or less we are where we should be. Okay, so we are more or less close to the faces, and we are Bob, he's the tallest one, so if we can see his face, we can see the other people's faces. Perfect. So now we have it. So now, exercise 5.1. Do the following. Create a script that contains all the examples that we gave above. So detects the faces, standing person faces, and makes the recognition. Okay. Once you have checked it works with a standing person, try doing it with the other two persons. So change the photograph, basically it's changing the photograph and the name. Okay. So pause the video and try it yourself. Okay, so you should have something like this. So if you ROS launch, I have it already here. So in this case, I haven't done a ROS launch. So, sorry, haven't done a ROS launch. So ROS run my face recognizer, face recognizer, and I have this recognize face. Yeah. So we wait, and there we go. So it's detecting Bob unknown. Let's do something like this so we can see it simultaneously. As you can see, it's saying no match because it's not detecting. Now I'm going to do a ROS run my face recognizer and move fetch base keyboard, and then we start moving. There we go. Way. And there we have it. So standing person. Then we turn a bit more. As you can see, the image feed goes slower. Okay. And there's Naoko. Okay, unknown. Perfect. So it's working. Fantastic. Now we return this here. And we close the program. Check. Perfect. Fantastic. So you should have something similar to this. Now, multiple face detections at the same time. So the Python script that we did, it can only detect one face at a time. So now create a new script able to recognize all the three persons at the same time. As I told you, you can retrieve these photographs. You can save them from here or retrieve them from the system as you wish. Or you can do your own pictures, of course. Okay? So I leave you, pause the video, and when you're done or you get stuck, let's see the solution. Okay, so I hope you managed. So you should have something like this. So standing person, Bob, and Naoko. Recognize multiple faces pi. This is the solution. It's one of the solutions. Obviously, you can do it in many ways. It's basically the same, just that you have now a Bob and a Naoko. But the rest is more or less the same. You do the encodings. So you load the file, you extract the face encodings of the three persons, you do the known faces and you save all the encodings here, and then you do the video capture, you divide it by half, so half the size. Then you do the face locations to detect all the faces that you see now in your video feed, and then face encodings. You say, okay, for each face location, so face locations, small frame, and you extract all the face encodings that you detect. And if you don't get any face encodings, then no face is found. If you do, then you have to do a match. So if, for example, if the match is the first one, so this one is Bob, because you had it the first one. So if it's the first one and it's not the second one and the third, so Naoko, I think it's Naoko, yeah, Naoko and standing person, then it's Bob, and so on. If you detect like two persons in the same place and for the same face, there's something wrong, okay? That's why there's something wrong here. And then again, you draw the squares, this is the same procedure, and then you print the image, okay? Just to a reminder, here the video capture, remember, you have to use the bridge object and you get the image. This is image here, okay? And this is self-recognized data, which you recognize the data that you extract from here, okay? So the pipeline would be, you get the image from the feed, head camera RGB image raw, then from here you call the callback calls the recognize, and the recognize does all the work for each frame, okay? Not for each frame, because remember, you're doing it, so one yes, the other one no. Okay, so you should have something similar to this. So let's start here. Naoko, and you can see now that it's detecting Naoko and Bob. And if we go here, you're getting, okay, I'm detecting Naoko and Bob, Naoko and Bob. Yeah? We don't need to move it. Perfect. Okay. So we close, stop this, and extra. So the extra exercise is you have to create the following program. Reads a topic where someone publishes the name of one of the three persons. So one, let's say I say Bob, okay? So I publish there. Use the face detection system created in previous unit to look for around people. Or you use this same system, Python, to use it as you wish. Once the robot has detected the person, so you look for persons, you say, okay, there's a person. You go close enough so that the face recognizer starts recognizing, and then it says, okay, it's Bob? Yes, okay, I found Bob, and the program finishes. If it wasn't Bob, then you have to memorize, memorize the person location and filter it, so that's not Bob, and then search for more persons and until you find Bob. Okay, then publish the face data so that you can use the face detection RViz elements to see the faces recognized. Okay, so you can, of course, you can use the ones that you used in previous one, and you can use also your own ones to give it a name, give it tags, and so on. We are going to do a course on this special RViz elements in the near future, but you can play around with them already, okay? So that's it, just talking about the project. Here you will have to find your owner, which she's called Olive. Olive is a small girl, and you have to look in the scene for persons. Remember, you have two persons there, Olive and a boy named Timmy. and you have to look for them, detect who is who, and go to Olive, not Timmy. Okay? And when you get there, you have to give her a paw. Like, move the paw around. And that's quite it. Thank you very much for staying with us till I think this is unit 5, so congratulations. You now know how to do object recognition, blob tracking, you know how to do face recognition and face detection. So congratulations. Now in the next unit, we will do people tracking. So if you liked the video, give us a thumbs up, and if you liked it, then subscribe for more videos like this one. So see ya.